Hi everyone, this is topic 4.2 net ionic equations. This is taken from AP Chemistry College Board. And in this topic, I'll be talking about that what are the different types of chemical equations and how do we actually write the final net ionic equation. So let's get started. Now, first of all, we already know that what is a chemical reaction. A chemical reaction is where the reactants are reacting to make the product. So on the left hand side of the arrow, whatever we write, those are the reactants, and on the right hand side of the arrow, those are the products. Now in this case, we are reacting CH4, that is methane, with oxygen to give CO2 and water. Now in this whole thing, you can see that these numbers are written before the molecule, before the formula of the molecule. Now this thing shows that how many moles are basically reacting in here, and this thing is called coefficient. So the coefficients are involved whenever we need to write the balanced chemical reaction. Now, first of all, let's tell you that what is the law of conservation of mass. Now, I'm taking the same example, that is methane is reacting with oxygen to give carbon dioxide and water. Now, you can see here that on the reactant side, the total mass of the reactant is 80 grams. And in the product also, you can see that the total mass of the product is also 80 grams. Now, the law of conservation of mass says the mass is neither created nor destroyed. It remains the same in every reaction. Whether you are taking with any quantity of the reactant, the product mass will be always same. Now, before writing the net ionic equation, we should be knowing that what are the valencies of the different elements. Now, to get to know about that, I have included this valency table. Now here, this is a periodic table where you should be knowing that all the elements of the same group are basically having the same valencies. For example, if I'm talking about group 1, it has a valency of +1. Now what does that mean? This means that group 1 elements likes to lose one electron to get the stable configuration. Stable configuration means the fully filled outermost shell. Now similarly, the group 2 elements will be having +2 valency, and the transition metals can display a number of valencies. They can have different valencies. Each element can show different numbers of valencies. Now here, till here, there are metals like the group 1, group 2 and the transition metals are the metals, and on the right hand side of the periodic table, there are non-metals. The group 3 shows a valency of +3, group 4 shows a valency of +4 or -, and the group 5 has -3 valency, group 6 has -2 valency, and group 7 has -1 valency. What does this minus tells you? That these elements like to gain the electrons, and when they gain the electrons, they get the minus charges. Group 8 has 0 valency. It means that it doesn't want to lose or gain electron. Why it is so? Because it already has a fully filled shell. So it likes to remain in the same state. Now how does these valency table help in the net ionic equation? Let's see. Here I have taken an example where the molecular equation or the chemical equation is NaCl is reacting with AgNO3 to give NaNO3 and AgCl. Now whatever is written in the brackets, these are called the state symbols, and these tell you that if they are in the solid form or the liquid form, or AQ means they are in the aqueous form. Aqueous form means they are in water, dissolved in water. Now, to write the net ionic equation, first of all, we need to write the total ionic equation. And how do we write it? As we split the metals and non-metals, or the metals and the polyatomic anions. For example, in NaCl, NaCl will be split as Na positive and Cl negative. As Na is in group 1, so it will have +1 valency, and Cl is in group 7, so it will have -1 valency. Similarly, AgNO3 will be split as Ag positive and NO3 negative. We will keep NO3 together because it is called polyatomic anion. And when they all react, the NaNO3 is formed. So again, NaNO3 will also be split as Na positive and NO3 negative. And AgCl, as it is formed in solid form, so it will not be split and it will remain as such because it is not in the aqueous form and it is in the solid form. Now the next thing is we need to cancel the ions which are same on the left hand side and the right hand side, and these ions are called the spectator ions. So we will cancel Na positive on both the sides. We will cancel NO3 negative also, as it is also on the both the sides of the arrow, and we are left with Ag positive plus Cl negative gives AgCl, and this is the equation which is called the net ionic equation. Let's see one more example. Now this is the reaction where Ki is reacting with PbNO3 whole twice to give PbI2 plus 2KNO3. Now the first thing is you need to see that the reaction is balanced or not. If it is not balanced, you have to balance the reaction first. Then we will write the total ionic equation. Now whatever is in the aqueous form, we will split them into cation and anion. That is, Ki will be split into K positive and I negative, but make sure you are writing the coefficients along with. Then the PbNO3 will also be split as Pb2 positive and 2NO3 negative, and PbI2, as you can see that it is in solid form, so we will not be splitting it, and KNO3 will be split as K positive and NO3 negative. Now the next thing is we need to cancel the spectator ions. So you can see here that K positive will get cancelled and NO3 negative will get cancelled because they are the spectator ions, they are on the both sides of the arrows, and we will be left with Pb2 positive, 2I negative and PbI2 on the right hand side. So this is the net ionic equation which we will get after all of the steps. If you like this video, then please subscribe the channel and press the bell icon.